The secrets of the sun are hidden in how energy travels up through its layers out into space. The sun's energy starts in its core, a giant fusion engine where hydrogen atoms are turned into helium atoms. The energy produced there moves up through the convection zone to the sun's surface, the photosphere. Moving magnetic fields contribute extra energy along the way. As energy moves outward, the temperature continually drops. This is just as one would expect while moving away from a heat source.
Up until that point, everything makes sense in that the hottest part is in the middle and everything gets gradually cooler as we move away. But then something very interesting starts to happen, which is that it starts to get hotter again.
This layer, where the temperature mysteriously begins to rise again, is called the chromosphere. It lies in an interface region between the photosphere and the corona, the hottest and outermost region of the sun's atmosphere. Observations from the IRIS mission will help distinguish among numerous theories on how the corona is powered.
IRIS will show the solar chromosphere in more detail than has ever been seen before. It will be taking images and spectra of specifically chosen wavelengths of ultraviolet light, and these will be the highest resolution and perhaps more importantly at a more rapid rate than has ever been done before.
The interface region is the greatest source of ultraviolet light that impacts the Earth and the space around it. Only a specifically designed spacecraft can image the wavelengths of light needed to study the chromosphere. Advanced computer modeling will enable scientists to interpret the data and better understand how the energy moves through the chromosphere.
The light from the chromosphere is difficult to interpret because of the complicated interaction that the light has with the matter. It bounces around, if you will, many times before its final bounce towards us. And this means that that interaction between light and matter needs to be modeled in great detail, due to not just advances in computational power of computers, but in the computational techniques that have been developed by the IRIS team. We are in a position to do this.
It takes only a small fraction of the chromosphere's energy to power the corona.
Although the corona is extremely hot, millions of degrees, it's at a low density, so it doesn't actually take a lot of energy to heat it to that temperature. The chromosphere, on the other hand, is a much higher density, albeit lower temperature. And there's much more energy deposited in the chromosphere than the corona. So that a tiny fraction of that energy in the chromosphere escaping into the corona is plenty to power all of the processes that we see, from heating to such extreme temperatures to driving the solar wind that fills the whole solar system, impacting all the planets, including our own. We hope to better understand these fascinating and important processes with IRIS.